So the best we finished is second place with 1,767 miles per gallon.
Dude, that is crazy.
It's insane. I mean, you can almost drive across the country, you know?
What power is this car?
It's a 35cc four-stroke, so it's a Honda GX35, and it's run on ethanol.
And is there a special ethanol class that you guys are running in?
There is. So there's an alternative fuels class. There's also gasoline, diesel, other things like that.
And why did you pick ethanol?
So no two cars from the same institution can run the same fuel source. So we're limited to either diesel or ethanol at this point. Ethanol burns really clean. So we went with ethanol. So we started in 2007, 2008.
But your first year?
So this is our first year for this car specifically.
What's the best that you've done?
So the best we finished is second place with 1,767 miles per gallon.
Dude, that is crazy.
It's insane. I mean, you can almost drive across the country, you know?
Yeah, and tell me how the car works, right? People might think that you're on the gas all the time, but that's not how it works.
No, so heat engines are very inefficient. That's just their nature. You know, in order to counteract that, we only drive just a small percentage of the time. So you have to average at least 15 miles per hour. And so basically we'll drive, you know, from 0 up to 18, turn the motor off, and then coast back down to 12, turn the motor back on, and continue that boosting, coasting process.
Why 15 to 12? Is that a magic, most fuel efficient number?
So they set 15 as the minimum.
Right.
So you kind of, depending on your gear ratio and your motor power curve and things like that, you kind of choose the range that you want to stick within. So not all teams do it that way.
Now you've been testing. How far are you getting on this vehicle?
So this one's not quite as efficient. You know, obviously we haven't had the body on it or nice bearings and things like that. But the best we've done is a gasoline equivalent of 800 miles per gallon.
And where do you hope to get to with it before you go down to Houston?
Well, we'd like to break 1,000 here. We're not sure if that's going to happen, you know, depending on the body and things like that. But in Houston, you can make, you know, 20 to 30% more power. So we think in Houston we'll definitely break 1,000.
And is that because you're at sea level?
Yeah, that's just because of more oxygen.
Yeah.
So what you're sitting in front of right now is the legacy car for the CU Shell Eco Marathon team. It's about 8 years old now, and we've got a carbon fiber body that is actually the legacy component of it, and we've got a 49cc single cylinder four-stroke engine that powers the whole thing.
And tell me about the clutch.
So the clutch is actually electronically actuated. So we've got a stepper motor on with a camshaft and a gear reduction, and it actually moves the lever to actuate the clutch.
And this is the car that took second place, right?
It is.
Yeah, and how have you guys changed it? How have you improved it? What have you done to it?
So one of the main modifications this year was actually that clutch component that we were just talking about with the electronic actuation. One of the other main things we've been doing is a lot of EFI tuning. So that's our electronic fuel injection. And so what we have is a whole bunch of feedback from the sensors. We've got a pressure sensor, an O2 sensor in the exhaust, and our angle on the encoder. And what that will tell us is how the engine is running, and so we can set a target AFR and actually change the amount of fuel we're injecting when we're injecting it in the spark angle for the engine.
Wow, that sounds pretty complicated.
It is.
And what's your kind of target MPG?
So our target for Colorado is going to be about 1,400 MPG. If we can hit that, then we know that we'll hit about 2,000 MPG in Houston, because the air is so much denser. You've got a lot more oxygen in the air, and you've got, you know, more humidity and all that going on as well.
So is this something fun to work on? Do you enjoy this?
Absolutely.
Yeah, what's the best part of it?
You know, I really just enjoy getting to work on a project that's really, really hands-on. You get to go down into the lab and actually turn wrenches and change things up, and maybe it'll work and maybe it won't, and you get to find out. We actually have a tuning strategy that we implement here, but when we go down to Houston, all of our values are completely changed. So we'll go down to Houston and have to essentially retune again from the ground up.
Yeah, and you go ahead of time to make sure you can do that?
Absolutely. We're actually leaving on the 21st this year. Competition, even the preliminary stuff, doesn't start until the 24th.
And is there like a nemesis like that CU has, or is it doesn't?
Not particularly.
Yeah.
I mean, we're competing against, 150 different teams, so we just go down and find out how we're ranking among the pack.
All right, and if you were to build this from scratch, how much would it cost?
About $30,000.
Wow, that's a lot of money.
It's mostly the carbon fiber that'll do that.
So the best the team's finished is around 3,500 in the U.S., and there's also one in Asia and in Europe, and they finished pretty well over there.
Okay, so 3,500 miles to the gallon, right?
Mm-hmm.
Which seems astronomical.
It is, yeah.
But you have no air conditioning.
No, you can't bring anything with you. No friends, no luggage.
And I take it not much of a lunch either, because probably the lighter you are, the farther you're going.
Yep, yeah, we joke, we just call us car jockeys.
So the smaller the driver.
Exactly, less weight.
And I think people might be thinking this is purely a mechanical engineering exercise, right? But it's not. I mean, you've got computer science, you've got
There's some
engineering, you've got electrical.
Absolutely.
Because I take it there's a computer that kind of controls how.
Yeah, so for that car, they're using a National Instruments Rio board, and there's a lot of PID control that goes into that, mostly for the clutch. But they wrote the code that controls the whole engine, so as far as AFR and spark timing, everything like that is written and controlled by our team.
What kind of clutch is on this vehicle?
So this one just has a centrifugal clutch, just like what comes on it from the factory. Basically, we made custom clutch housing and things like that. But in this, just for time, in essence.
And you still have to do the body. Is that going to be carbon fiber as well?
It's not. So this car was kind of founded in the idea of a more versatile budget car. So things like aluminum tubing that are cheaper. So we actually built a 4-foot by 8-foot vacuum forming table. We'll be making it out of polycarbonate sheet.
So how much all in does this cost?
It depends on if you're going with materials that we had laying around or what we used. To give you the long answer, so we've got like some magnesium plates on here that we just use because they're around our shop, which is probably $1,000 in magnesium and things like that. So far this car, and the body and the molds and everything else we've used are about $3,500.
That seems reasonable for a bunch of college kids.
It is, compared to a $12,000 carbon fiber body.
Yeah, and if people are interested in supporting CU or supporting the team, where do they go?
Absolutely. So we have a Facebook page. It's the CU Boulder Eco Marathon team, and we're also in the process of setting up a website where you can donate to our fund as well.
All right. People, do you want to help these guys get that magic 1,000 MPG?
We're working on it.
Go for it. Thank you very much.
Thank you.
Thanks. I love the fact that your feet are up against 2 brake pedals from a bicycle.
A couple of bike brake. Yeah, so the idea here is that they're very adjustable. So I'm kind of a short guy, but if a tall guy drives it, you can push them back. You can rotate them.
Yeah, kind of walk me through the vehicle. I mean, it looks like it's specifically built for being very fuel efficient. So kind of walk me through the front to the back of it.
All right, so first of all, we wanted something that was very low profile. As opposed to the first car that we have, we're keeping these wheels on the inside, so they're nice and short. That's part of the reason. These are special Michelin tires that they build just for this event, so they actually have a really low rolling resistance. So low profile, so that means the driver is pretty much laying, down as far as they can.